kita mengundang beberapa pembicara dari luar LIPI untuk bicara, dan dari dalam LIPI juga untuk bicara khususnya tentang relasi antara teknologi dan aspek-aspek sosial dan kemasyarakatan. Dan kebetulan siang ini kita mendapat kehormatan bisa mengundang Profesor Liang Li dari Reconstruction University untuk berbicara tentang visualisasi cagar budaya atau visualisasi warisan budaya. Penggunaan teknologi dalam visualisasi cagar budaya atau warisan budaya. Tapi sebelum kita masuk ke dalam paparan dari Profesor Liang Li, saya akan cerita sedikit konteks dari webinar siang ini. Jadi webinar ini selain tadi saya sudah kemukakan merupakan bagian dari kegiatan program kajian STS di P2W LIPI. Webinar ini juga merupakan bagian dari kerjasama penelitian antara P2W LIPI dengan Reconstruction University, Art Research Center di Reconstruction University, dan dengan Balai Konservasi Borobudur dan dengan Direktorat Jenderal Kebudayaan. Dengan tujuannya adalah kerjasama ini melakukan penelitian dan melakukan perekaman digital Candi Borobudur, dan juga diharapkan nantinya juga akan menghasilkan sebuah produk ya yang berupa pemodelan model 3 dimensi dari Candi Borobudur. Nah, saya pikir ini akan sangat menarik karena seperti teman-teman, bapak-bapak, ibu sudah tahu bahwa teknologi digital itu sangat bermanfaat sekarang ini dalam recording dan dokumentasi warisan budaya. Jadi saya lihat di sini juga para peserta banyak yang berasal dari kalangan arkeolog, dan juga ada terima kasih, selamat siang Mas Amir Hidarta yang juga tertarik untuk bergabung. Apa kabar Mas Amir? Ya, sorry di mute ini nampaknya ini, tapi nanti kita ngobrol-ngobrol. Oke, jadi Mas Amir ini kurator dari Museum Seni Pelita Harapan. Jadi kemudian saya lanjutkan lagi tadi pengantar dari saya bahwa selama nanti yang akan dipresentasikan oleh Profesor Liang Li, selain untuk menguraikan secara lebih luas lagi teknologi machine learning dalam perekaman objek-objek warisan budaya, tetapi juga Profesor Li juga akan menyampaikan sedikit hasil dari kegiatan kerjasama penelitian kami antara LIPI, Reconstruction, dan Balai Konservasi Borobudur. Jadi ini nanti selain beliau akan menguraikan secara umum, tapi beliau juga akan mencoba untuk menyampaikan sedikit hasil penelitian tersebut. Dan kami bekerja sama dengan Art Research Center di Reconstruction di bawah koordinasi dari Profesor Satoshi Tanaka yang kebetulan juga sekarang bisa hadir dalam acara siang ini. So I think sebelum saya berikan waktu kepada Liang Li, saya akan sedikit memberikan pengantar singkat tentang siapa beliau ini. Profesor Liang Li ini adalah seorang computer scientist. Jadi beliau mendapatkan gelar PhD dalam ilmu komputer dari Hiroshima University, dan saat ini adalah associate professor di Department of Computer Science di Reconstruction University. Jadi ini akan menarik sebagai contoh bagaimana kerjasama antara berbagai disiplin ilmu dalam konteks perekaman dan kajian warisan budaya. So, Professor Lee,
yes,
thank you for joining our webinar and for accepting our invitation. It is a pleasure to have you here this afternoon.
Thank you very much.
And I already introduced you to the audience, so I think you can start by start your presentations. And before that, probably just to give you an estimation of time, you have like around 45 minutes for your presentation, and then we will be opening the session to the public for Q&A.
Okay, no problem.
Buat bapak-bapak, ibu-ibu, kami mohon maaf nanti untuk sementara audio akan di-mute dulu. Tetapi kalau misalnya nanti ada yang ingin bertanya, bisa menggunakan kolom chat, menuliskan pertanyaan di sana, atau juga nanti bisa menyebutkan nama di kolom chat dan kita akan berikan akses kepada audio nanti pada saat Q&A. Mohon jangan lupa nama dan pada saat untuk memberikan pertanyaan. Dan pertanyaan bisa ditulis dalam bahasa Indonesia atau bahasa Inggris. Nanti kalau bahasa Indonesia nanti saya akan terjemahkan kepada Profesor. Okay, so Professor Lee, the time is yours, please.
Okay. Thank you very much, and I'll share the screen and start my presentation. So, okay, can you see the screen? It's no problem?
Yes, no problem.
Okay, thank you very much for the introduction. And today I'm gonna talk about machine learning for heritage visualization. So machine learning, especially deep learning, is a very hot keyword recently in recent years. About learning, I just saw the very good example. For example, Dr. Fajal just introduced me with a speech, but only I can recognize was Hiroshima University, ResNet University, and my name. So because I think it's a learning problem because I don't have knowledge about Indonesian, so I can only recognize some keywords the same as English. So in fact, this is also a learning process. I'll give some more detailed information and the introduction later. So this research, of course, is in collaboration with LIPI and the Probability Conservation Office, and also with Professor Tanaka and Dr. Yamaguchi. So this is our target. I will introduce our whole project, and of course, some basic knowledge about machine learning, especially deep learning, based on this project. Then how we can visualize a heritage and use a probability as an example. For the visualization and digital archive of heritage objects are quite widely carried out worldwide. But in fact, currently, for the big amount of data, for example, the big amount point clouds, the visualization technology are quite not as good as recording technology. So we have a lot of data that already recorded, but not visualized. And also for recording some digitally recording some heritages, it's very difficult to use the normal technologies, for example, the laser scanning or the photo scanning or something, because some heritage already we cannot access or we cannot see from outside. So today I'm gonna talk about the whole project. And for this part, we're using different technologies to visualize different objects. Okay, so this is a Borobudur, and of course, as you know, it's a UNESCO World Heritage Site and the largest Buddhist temple in the world. And also it has the largest and most complete collection of Buddhist relief in the world. It totally have 1,460 panels of reliefs like this. So those photos are took by myself. I visited Borobudur 3 times. So, but unfortunately this year we cannot travel aboard. So Hopefully next year we can visit Indonesia and we can visit Borobudur again. So I love nasi goreng very much and also Indonesian coffee very much. So I hope we have the opportunity to visit again. So digitally archiving of a complex 3D structure, and in this case, we want to visualize a Borobudur. So before visualizing Borobudur, we have to consider some problem in digital measurement or visualization. The first one is for the cultural heritage. During the measurement, we cannot make any damage to the heritage, right? For example, we cannot break them down, or we cannot drill them down. And of course, we cannot use some harmful method to measure the 3D objects. And the other issue is to make a success measurement, and we have to use that to further analysis of the data. That means we have to make the measurement as more accurate as possible. That means accuracy is very important in measurement. Of course, there are some measurement methods, for example, just use photos, or we can just use Kinect to get the 3D environment or 3D object, the shape of the 3D object. But sometimes if the accuracy is quite low, then we cannot use it for further analysis. So that's also the problem. So for the different kinds of heritage, we have to use a different method to visualize them. So here we can see for visualizing Borobudur, we have to consider 3 different kinds of data. The first one is a surface, the surface of Borobudur temple for the whole temple. Of course, the surface, we can use 3D scanning because we can see the surface outside. And the other one is the hidden relief. As you may know, some reliefs are hidden behind the stone wall. So that's a problem of when we want to make the 3D model of the reliefs, because we no longer can access them. And the third one is underground structure. Because underground structure we cannot see from outside, and also we don't have photos. Then what we have is only a 2D CAD data. So we have to make the 3D model from the 2D CAD data as much as possible. So first, I'll introduce the project one by one. The first one is the surface, how we can get the information of the surface and how to make the 3D model of the surface. Now, this is in fact, we can say this is the most easy one, because it's we can use a lot of different 3D scanning method. And then after we scan the 3D information, we can change it, save it as either point cloud, or we can save it as 3D mesh, right? So what about the 3D scanning? How we can do 3D scanning? Maybe you've heard of, for example, laser scanning, photo scanning, CT, or structured light, a time of flight, and LIDAR, and much more. So all the different equipment or the different methods are for 3D scanning. All they are doing is detecting and constructing the 3D information of a real world object or environment. The most one we commonly seen are, for example, the Kinect, or this is an iPad Pro. So as you know, maybe you see the iPad Pro, the commercial. So they say, okay, the new iPad Pro, we have a LIDAR camera, so we can capture the 3D environment of your room, for example. And then we can put some AR object inside the virtual, the captured environment. That's a LIDAR. The LIDAR, in fact, is a little bit different, but sometimes we can see the same from the Kinect version 2, because it's based on time of flight. Time of flight means the traveling time of the light. So from the LIDAR, it will just project a laser beam. and then calculate the time difference when the laser beam just hit the object and returned. Then calculate the distance. So the distance was calculated by the flying time of a laser beam. This is the same technology, but not LIDAR used in the Kinect version 2, but it's also a time of flight-based technology. But maybe you know the first version of a Kinect, the Kinect version 1, they were not using time of flight, but they were using a different technology. It's structured light. That means the Kinect will project some partons and then use another camera to capture the parton and calculate the different shape of the parton, and then calculate the shape, calculate the 3D shape of the environment. So even it's the same Kinect, but the different generation, they use different technologies. And for the heritage reconstruction and heritage archiving, usually we use two different methods. As you may see, this one is a laser scanning. Laser scanning is a very precise technology that can measure the very detailed surface and also with the color of some objects. But here I want to introduce another technology that commonly used called photo scanning. What does photo scanning means? Because these two technologies are totally different. The laser scanning calculates the time of the beam, the flight time of the beam, right? Also laser. But the photo scanning is a computer vision based method. It's based on computer vision to calculate the 3D structure of the object or the environment. So the concept is like this, like why human can perceive a 3D environment, why we can perceive this room as a 3D environment, not only a 2D photo. Maybe let's try a very simple experiment. For example, if you open two eyes and you, for example, use two pen or pencils, then you try to put the tips together. If you open your two eyes, it's quite simple task, right? You can do it easily, or even with your fingers. It's much more easier. I think maybe the pencils are more difficult, but you can do it with your two eyes easily. But if you close one eye, please try this task again. You'll find it's very, very difficult to put the tips together. Or even with your fingers, it will get more difficult than two eyes, right? If you use one eye, it's very, very simple. But if you use two eyes, it's very simple. But one eye is more difficult. Why? Because you lost the information from two eyes. Why the information from two eyes are very important? Because our two eyes are not from the same direction. When we see, or we can say when we perceive an object, two eyes perceive the same object from different angles. That means from different viewing points, that we can get the different information. Let's think maybe if we have 3 or more different viewing points, then we can get the idea of the object, that how the shape is, or how the distance from the point to from the camera to a specific point. And then based on this method, we can reconstruct the whole shape of the object. So in fact, this method, there are a lot of computer vision based methods. For example, SFM called the structure from motion. That means only you have one camera, or you only use one eye, you close one eye. But if you move, then you can see different angles, right? So that means a structure from motion. So you can perceive, or you can get the information of the camera. You can calculate the situation by different angles, or even the photos are taken from different times. That's structure from motion. After you reconstructed the points, then you can use another method called multi-view structure, multi-view stereo. It's MVS. The multi-view stereo will calculate a more precise detailed structure, detailed textures of the object. So those methods are computer vision-based methods. They never use a time of flight, but they reconstruct the object from different photos, from several photos. That's a problem. That means we have to have different photos. So this method, in fact, is not new, but recently we got a much more easier way to do that. For example, we can use Metashape. Maybe as you know, previously this software called the Photoscan. Now they changed the name to Metashape, but in fact it's the same software. This software is based on the SFM and MVS technology and can use to construct the 3D model from photographs. So this is a real thing that I use to reconstruct this model. So these photos are taken from a drone. Of course, this data was received from our Indonesian friends. So we use those photos from different angles or different photos from different parts to get the whole structure of a 3D environment. This is a photo scanning. Then for visualization of the relief, for example, like this part, this is 4 different panels of Karmawibhangga relief at the first level. We can use 3D photo scanning and just took photos from different angles and then use a computer vision-based method to reconstruct the model. That's quite easy. But of course, when you took the photos, you have to follow some rules. For example, every 2 photos have to have some overlap parts. Then you can calculate, you can make the blending, or we call it a registration. You can make a better seamless result. So you can get a more accurate results. Thanks to the technology development, then currently the photo scanning technology can get a very, very high accurate result. So that's very good for the historical studies and for the 3D modeling. And then for the whole structure, we can use 3D scanning. Either it's photo scanning or laser scanning. Of course, in this case, we use photo scanning. But there's some problem because, as you may know, this is a visible panels of Karmawibhangga relief. And we also have 156 panels are buried behind the wall, right? It's buried behind the wall more than 100 years ago. So this is current situation. It's a current situation. It's called the hidden foot, right? Karmawibhangga relief. Almost all the Karmawibhangga reliefs are buried behind the walls, except 4 panels of the southeast corner. But we have a good news and the bad news. I don't know which one do you want to hear first. Maybe I'll say the bad news first. The bad news was the photo is like this. The photo was taken from only one angle. We only have one photo for each panel. Because previously I just introduced, if you want to use a computer vision-based method, at least we have to have 2 different photos from 2 different angles. Of course, as much as possible, the more the better, right? But currently we only have one, that we cannot construct the 3D information from only one single photo. That's a bad news. But the good news is, at least we have one photo. At least the quality of the photo is quite good. We can use this information to try to reproduce the depth information. That means the 3D shape or the 3D the shape of the 3D surface of the panels. Then there's a problem, as I introduced. For the visible relief panels, we can use photo scanning to get the photo scanned 3D point cloud. But for the hidden relief panels, how can we do that? We cannot use laser scanning because it's already buried. And also we cannot use the 3D photo scanning, or even we cannot reconstruct it from different photos because we only have one photo from a single angle, a single image. So that's a problem for the hidden relief. So the second part, for the hidden relief, we use another method to make the visualization, to make the 3D reconstruction. We use machine learning. So how we use machine learning to make a 2D photo or monocular photo to 3D surface. Monocular means only one angle or only one eye, don't have any depth information. So the idea is, if we don't have the 3D shape or the 3D model, but we have one monocular photo or single image, and if we have the depth map, the depth map means depth information for each pixel. Maybe you can see this depth map is like a shadow, but in fact, the gray value on the image have some meanings. For example, the brighter means further from our eyes, and the darker means closer to our viewpoints, our camera. So this is a corresponding pixel value to this monocular photo. So that means, for example, this part is closer and the background should be further. So if we combine these two together, combine the original photo and the depth map together, then we can reconstruct the 3D surface of this single photo, right? But the problem is how we can get the depth map, because we don't have depth information. We only have this information. How we can get the depth map? Then we use deep learning. And of course, deep learning is one method of machine learning. I will introduce a difference between AI, deep learning, machine learning, and supervised learning, and a lot of different hot keywords later. But now, we just consider a situation. So everybody, please imagine this situation. For example, here's an alien just visit our Earth for the first time, and he or she just see a cat and dog. When he sees a cat and the dog, do you think he can tell the difference? Which one is a cat, which one is a dog? I think he cannot tell the difference. Of course, he cannot say which one is a cat and which one is a dog. So why? Because he don't have the knowledge of what does cat look like, or what does a dog look like, right? Then we can see another example. Can you read this character? Do you know what does this word means? Maybe some of you can recognize. It's called a Borobudur. So it's a Borobudur in Japanese. Maybe some friends from Japan and some of you know Japanese, then you can read it immediately, right? But how about this? This is Chinese characters of Borobudur. It's called Polofutu in Chinese. Maybe less of you know this word, right? But I think everyone know this word, Borobudur, right? It's either in Indonesian or English is the same word, right? Borobudur. Everyone know this because you have the knowledge of this. You've learned about how to read and how to understand this letter, right? So you can read it. So this is that means the knowledge, how knowledge works in recognition, in our perception, right? Then we can see another example. Can you read this one? Do you know the meaning of this? maybe I can try to pronounce it. It's Kipskavivs or something like that. I don't know, because I just made it up. I think everybody think, oh, this is also means Brabdu, right? But in fact, it's not, because I just, based on Brabdu, I just +1. Next to B should be C, next to O should be P, next to R should be S. So I just +1, I just made up this letter. But even this is a fake letter, it's a fake word, but why you can have this idea that this means Brabdu? So this is the effect of learning. Because I just introduced 3 different words that means Brabdu. So based on this knowledge, then everybody have a guess that, oh, this is I predict this word should be has the meaning of Brabdu, right? So this is also the process of learning. Then let's go back to this situation. Then this alien, he just stayed in the earth, on our Earth for maybe 1 month or more, just stayed for a while. And he just have seen a lot of cats. And of course, then somebody or the cats tell him, so we are cats. And also, he has seen a lot of different dogs. And also the dogs or somebody told him that those are dogs. So let's imagine next time when this alien see a cat, so maybe he can guess out. So this is a cat, maybe in his pronunciation, it's a cat, and then next time it's a dog, this is a dog or something, right? Because based on this knowledge, based on his previous knowledge he have learned, then he can predict or estimate the future information, right? So this is the machine learning, or at least this is supervised learning, how supervised learning works. So this is a different concept of different AI technology or something. I just mentioned machine learning is here, and deep learning is here, and supervised learning is here. So what does supervised learning means? Supervised learning means you have to tell, for example, the alien the right answer, the correct one, right? So when he saw the different cats, somebody have to tell him those are cats, right? And for the dogs, somebody have to tell him those are dogs. Otherwise, he will not know. Let's back to this situation again. For example, that somebody told him those are cats and dogs are not adult, but maybe a little kid. What do you think he will learn? Maybe he will say, okay, those are kittens, those are puppies, right? No longer cats and dogs, but a different word because of the teacher, right? The teacher taught him different knowledge. So he only can classify the different things according to the knowledge he's been taught, right? So this is we call it supervised learning, or in Japanese is a kyoshi ari, means with a teacher. But the other situation is unsupervised learning. That means without a teacher. For example, he saw a lot of different animals with dogs and cats, and he will get some idea that, oh, there's some animals, all of the animals with 4 legs and a tail and 2 ears, 2 eyes or something. But after a while, he just figured out that some animals with a shorter nose, and the other group of animals have a longer nose. So maybe there are 2 different creatures, right? 2 different species. But maybe he will not know the shorter nose species called the cats and the longer nose species called the dogs, right? And of course, it's not depending on the length of the nose, but maybe he just figured out with some features of some characteristics of the different animals. But he will not know the name of the different creatures, but he can separate different creatures. That means clustering to make different objects to different clusters. It's a classic unsupervised learning problem, right? And in fact, there are also reinforcement learning. That means you have to set some rules first. You have to give a reward to an algorithm, give a reward and a penalty. So then the AI will make decision at the environment, right? It's called online decision, right? So nowadays, there's a lot of keywords are very hot. For example, AI. Everybody says, oh, currently AI is a very hot topic, and big data is a very hot topic. 5G is a very hot topic. And also you've heard about the machine learning, deep learning, neural network. But if you want to know the relationship, is all the relationship is on this table. The AI called the artificial intelligence. The artificial intelligence is a very big concept. So all machine learning and the other keywords are included in AI, in the area of AI. The AI means some computer just can make decision by himself or by itself, right? For example, let's think about a very simple example. For example, you just set up an alarm on your phone. So the alarm is an AI, right? Because you just set some rule and the program will follow this rule and it will sound according to the time you've set, according to the rule you just set. So it's a very simple AI. But it's not machine learning because the feature is not learned, or it's not that really intelligent, right? But machine learning is a much more smaller concept. Machine learning, maybe you can just pick up the features by yourself, but you have to tell the machine what to do. And if we use, for example, some correct answer to supervise the learning process, then it's called supervised learning. Otherwise, it's called unsupervised learning or either reinforcement learning. I just introduced before. So another very hot topic is a deep learning. I think everybody maybe heard of deep learning maybe from past 5 years or around that. Deep learning is to use a deep neural network to achieve either supervised learning or unsupervised learning or reinforcement learning. So in this case, in our project, we use deep learning. We use deep learning to achieve the 3D reconstruction of the Browadu panels. So let me introduce artificial neural network and deep learning a little bit. So these are neurons in our brain. Like each neuron is being connected, right? And with this connection, so different neurons just pass the information to each other. So this is a very simple artificial neural network. So for a neural network, of course, we have an input layer and an output layer. Input layer means information have to input to the neural network. And output layer gets some result. And other neurons in this neural network, we call it a hidden layer. Let's just think about this neural network. It works similar to our brain, right? The input layer, for example, input an image, for example, from our eyes, the scene we just saw. So input inputted into our eyes, and then our neural network, our neurons in our brain, just figure out what the scene is, right? For example, there's a scene of a computer just in front of me. So this is output is a result, gave some perception, right? So this is a computer. But this very simple neural network, maybe the output only 0 or 1. For example, this is a computer or not a computer, right? For example, 0 means it's not a computer, and 1 means this is a computer. So it's a very simple network. So how can we get the result? And how can we get this neural network works? That means we have to train this neural network. Like we have to train our brain, right? We have some knowledge about the dogs or the cats. If we never seen the cats or the dogs, we have no idea which one is a dog and which one is a cat, right? So the core problem is how to get the relationship. The relationship are here, right? So the input X, output Y. What's the relationship between each input and each output? For training, we have to use a lot of data to make different data to get the equation. And then we will solve an equation, right? We solve the equations. To get the relationship is also the weight of the equation of the parameters, right? So after the neural network's been trained, the next time we saw something, we can get the correct answer. It is how it works in our case. So we use the training data for monocular images and its corresponding depth maps, right? We have to use a pair. Why we have to use a pair? Because this is a supervised learning. That means we have to get the answer of each question, right? It's the correct answer. This is the correct answer to the question for the training, right? This is a monocular image and the depth maps. And then we put the information to the neural network. This process called training or learning, right? Usually we call training in computer science to train the neural network. In fact, this is quite similar with a previous example of the alien example that is different dogs and cats, and this is answer called this dog and cats or something. But this is a much more difficult situation because each pixel means a different answer. So after we train this one, then if we input an unknown monocular image to the trained neural network, then the neural network will give you an answer. This is a predicted depth map. So when the alien just sees a dog, then he will get an idea, okay, this is dog. And in fact, the output is quite easy, 0 or 1. 1 is a dog and 0 is not a dog. And if for the cats, then it's another output on another neural network. So maybe you are wondering now, how can we get this data? Because we don't have the data, the 3D information, then how can you get the depth map for the correct answer? In fact, we can use the visible parts, right? We also have some visible reliefs. Not all the reliefs are invisible, right? So we use the relief panels from the four Karmawibhangga panels that are visible, and also the upper layers of the relief panels to make the training data. That means the correct answer. So this is a teacher to teach the neural network to get an idea about how the corresponding depth information to a single monocular image. So this is a more detailed method of a more detailed algorithm of our method. So for the different monocular photo of the relief panels, it's a 2D, of course, and we use deep learning to get the intensity. That means the depth value, right? To get the depth value of the monocular photo. So this is a depth map. This is output of the neural network using deep learning. And then we use a linear transformation because I just mentioned the darker part means nearer to our scene, and the brighter part means further to our scene. So we use this one to reconstruct the 3D point clouds. So then you can perceive a 3D surface, right? But currently, the training data set, we use pairs of monocular photos and depth maps from 10 relief panels, 4 from the first level and 6 from the second level. And of course, maybe some of you know that the number of data is quite important. With more data, we can get a more accurate result. So why it's accurate, maybe according to the time, I just will not mention it, but if you're interested, we can discuss later. And this is our network. You can see this is like a neural network, and here the number means the dimension. It's a dimension of the network. And here's the input, and after a lot of different calculations, and then the output of the network will be a depth map. And of course, all the parameters inside the network already trained by our training data. So when you input a new data, then you can get a result like this. So this is our result of depth estimation by deep learning. So this is input monocular photo that from very long ago, right? And this is a ground truth. Ground truth means a correct answer. So the network was trained by using the pairs of a monocular photo and the ground truth. And this is the predicted depth map. And of course, this is a test data. For the test data, we didn't use this for training, right? Only for test. So this is correct answer. This is a predicted depth map, means output or our result. So you can see the depth map of our result are quite similar to the correct answer or the ground truth, right? So this is a numerical evaluation of the result. So the panel size is 2.7 meters multiplied 0.92 by 0.95. And the mean error by using cloud compare, the C2C means the cloud to cloud distance, was 0.0089 meters. That means less than 1 millimeter. So you can see the color means a difference. The red part means the difference are large, and the blue part means the difference are less, right? So almost all the errors are less than 0.08. So that means the accuracy is over 95%. And of course, now we are also developing different methods to improve our method. And one idea is to use some network based on more information, for example, age information. And also, the more data we can get for training, then the more accurate the output result will be. So this is a result. So the upper one is a photo scanned 3D model, right? We use different photos for the visible part. And the lower part is a transparent visualization that we made using a method based on Professor Tanaka's method called the SPBR, stochastic point-based rendering. Can make the 3D model transparent because this part already hidden behind the wall. It is buried behind the wall. So you have to use transparent visualization to see it, right? If you put this one here. So let's make it bigger. So this part is transparently visualized for the reconstructed part. Okay, so this is how machine learning worked in our case. And finally, I will introduce how the underground structure can be reproduced by using a 2D CAD data. Because we only have this photo, it's not a photo, we only have this 2D CAD data. It's like a blueprint, right? So how can we just reconstruct a 3D shape based on only a 2D information. In fact, we cannot use 3D measurement, either laser scanning or photo scanning, because it's underground. And also, we cannot use machine learning in this case because the training data is not enough. So what we are doing is we just use like a sweep model. We create a polygon mesh by interpolation of the 3D CAD data. We just interpolate the data between the two directions to a 3D polygon mesh. And then from the mesh, we use random sampling to make a 3D point cloud. So in fact, I also prepare some detailed information about this algorithm because of time, I just skip it. So if you're interested in this detail, we can discuss later. So the main idea is to use polygon division and then generate new point clouds based on the interpolation. Okay, finally, we can just fuse the different data together. We have a 3D scan point cloud from the real visible part and reconstructed relief model by using deep learning for the hidden part from one single angle old photos, right? And then also we have reconstructed underground structure only from 2D CAD data by drilling survey. And then we fuse all the data together and visualize them, use transparent visualization based on SPBR. Then you can see the whole structure of Barbadoux and the underground part of the foundation part, and also some very detailed reconstructed panels, which we cannot see usually. So this is a visualization result by fuse transparent visualization. And this is also the fuse transparent visualization result by using the data that I previously introduced, the data that captured by the drone, right? So this is how it works, how the visualization and how machine learning works in our case and for the heritage visualization. And finally, I want to say something about the visualization that somebody may think that visualization just make some object looks prettier, right? It's only to make things more beautiful. But in fact, visualization have a lot of different applications. For example, visualization can make some invisible part visible. The buried part, we can visualize some buried part that usually we cannot see, right? So visualization is not only a tool to make objects make more prettier, to make more beautiful result, but also a tool to support researchers to analyze the data, to get some new knowledge or new perspective about the data. Of course, in this case, the cultural heritage, to have some new findings about the cultural heritage. Okay, thank you very much for listening. And I want to thank all my friends from Indonesia and thank Dr. Yamaguchi and Professor Tanaka for this project. Thank you very much.
Okay. Yeah, thank you very much, Professor Lee, for the very nice presentation and then for the update of our ongoing project. And I think I really enjoy this, both the presentation and also the visualizations. And I think it helped us to now to think of different ways of managing cultural heritage. Usually you have to have a direct access to the cultural heritage, but with these kind of new tools of visualization, I think the management of cultural heritage can enter a new dimension in which you not necessarily have to deal directly with the object, except at the time when you need to record the information. But the rest of the processes can be done uh, uh, in a digital way. I think in Indonesia now we are starting to use this digital technology to create different kinds of visualization of cultural heritage. Some people have already learned the way how to do it, but I think one thing that you provided us with the new information is the way how we reconstruct something that is already hidden, and using the available materials in order to reconstruct the 3D visualization models. And I think that is very important for us, since a lot of data in our cultural heritage of cultural heritage objects, sometimes we don't have enough data, but we have different kinds other data, like from archival records and from different kinds of images and so forth. So then using this kind of deep learning techniques and machine learning techniques, we can utilize that data and then combine that in order to make a visualization that can be used further for the cultural management practices and policies, but also for the research purpose. I think, and that's why I thank you very much. And then I'm glad that we are able to collaborate in the project, and then this project is still ongoing, and I hope next year when the pandemic is kind of over. I'm not well. Over is very strong word, but I think it's just declining. Probably we can push further with data collecting and other types of analysis.
Yes,
Jadi
thank you very
begitu,
much.
Bapak-bapak, Ibu-ibu. Sekarang saya buka, so I'll open the Q&A discussion if anyone want to ask questions or look for some more clarification, and then I will give a time to the audience. Silakan Bapak-bapak, Ibu-ibu, teman-teman, kolik, kalau misalnya ada yang ingin bertanya, bisa langsung mencantumkan nama di kolom chat. Nanti kita akan beri akses, atau kalau tidak mau langsung ngomong, bisa juga ditulis di kolom chat kalau ada pertanyaan yang ingin disampaikan kepada Profesor Lee, atau juga kalau mau tahu lebih jauh tentang proyek ini bisa juga ditanyakan kepada saya. Oke, sebentar saya cek ke, nampaknya di sini belum ada pertanyaan. Oke, sebentar, ini ada satu yang masuk. So we have a question from Natasha Sandra from the Prambanan High School. So she's asking what's the difference between machine learning and deep learning? Can we predict depth map just to use machine learning, then deep learning to predict the depth map? Really want to know your answer. Thank you, really want. Thank you. So it's basically she's asking about the difference between machine learning and deep learning, and probably the sensei can explain it a little bit more more clearer to the Natasha.
Yes,
Okay.
thank you for the question. And in fact, machine learning and deep learning, in fact, deep learning is one part of machine learning. Machine learning is a broader concept than deep learning. Deep learning itself is an algorithm to achieve machine learning. But usually we say currently, because deep learning is very hot, so when we mention machine learning, we think about the traditional machine learning methods that we have to extract the features by ourselves, by a human. And deep learning, for example, deep learning using neural network can extract the features automatically from the neural network. Let me just give a very simple example. For example, to classify cats and dogs. For deep learning, as I mentioned, you only have to tell the neural network or tell the AI, tell the machine that this is a dog and this is a cat, and you just input a lot of training data. Then the machine or the computer can figure out the difference or figure out the feature by itself. But for traditional machine learning, you have to extract the feature by yourself. For example, you have to tell the machine that dogs are, for example, long-nosed and with a furry tail and usually bigger than cat. So you have to define the features by yourself for traditional machine learning. So that's a main difference. So you also mentioned about, is that possible to predict the depth map just use machine learning? It's possible. In fact, it's possible, but you have to define a lot of features by yourself. For example, you should tell the network, it's not necessarily a network. Maybe you should tell your algorithm that what kind of features should be considered as deeper and which kind of features should be considered as thinner, that are nearer. So traditional 3D reconstruction method or traditional method of depth map prediction based on traditional machine learning method exists and is possible, but it requires a lot of technique to define the features. And sometimes the result is not as good as deep learning. And of course, sometimes currently a lot of people think about deep learning. So deep learning is everywhere, and deep learning can do everything. But the problem, in fact, I think it's not perfect, because deep learning cannot deal with every problem. It's just perfect for our case in this project. And second, some people now doubted deep learning, that for a deep learning, because you only have to input the training data and then train the neural network, then you just get the output. So, but what's inside the neural network? It's like a black box. So we don't know about what's inside. So somebody is worried about the deep learning, that we just use deep learning as a tool, but we don't have really much knowledge about the deep learning. So that's some problem of deep learning. But currently, a lot of people now working on some research about the understandable network, that they want to figure out how it works and want to explain the result of the deep learning result. So I hope I answered the question.
Yes, thank you, Professor Lee. I think it for me it answered the questions, and then I think it's the point that you raised at the end of your answer. It's very important, because learning about thinking about deep learning as a black box, because
Yes.
it's very important for in a heritage studies, for example. Then we need to know whether this kind of a reconstruction reflect the actual
Yes.
state of the object. And I think if we don't understand or do not know what is going on within that black box, then probably the rendering, the result will be slightly different from what we understand as the actual object. But this is another issue, I think.
Yes.
Yeah, I'll give time to Mbak Yulan. Mbak Yulan, Dr. Yulan, Dr. Tung has yes. We cannot hear you.
Okay, Lemley. Yes. Hello.
Hello.
Can you hear me?
Okay. Now it's yes, no problem.
Okay. Yes. I would like to know. You're always talking about machine learning.
Yes.
What is the researcher role in influencing the machine actually, and how you try to organize it based on your thinking, not the machine thinking? How you explain that connection in this sense? Because at the beginning, you also talking about the correlation between variable, right? Or between things. So I would like to know how trying to understand where our position as a researcher, especially the one is not doing hello?
Sorry.
Can you catch my meaning? Hello?
Yeah, your voice is breaking out. We cannot hear you. You're muted. You have to unmute your. You have to unmute your.
Okay. What I mean is that because we also have our interest in doing this, so I would like to know our position as a researcher. How you clarify that one?
How to classify machine learning?
Clarify.
No,
I mean,
the researcher, the human researcher.
Oh.
In that relation to the machine learning, how much influence you have about your ID to the machine?
Yeah, I think your voice is breaking out, Batum. Putus-putus. So I'll just repeat what you the major point that you're asking. Actually, she's asking you the role of the researcher. It seems that machine learning, it's you leave everything to the machine, but
yes,
what is the role of the human, the in whether it has an influencing role, or any kind of role, and what do you think of the role of the researcher in in this process?
Yes, thank you for the question. And yes, it's a very good question. That if you have an AI and the AI just took the job, then how about the human? Then the human being, what's about the role of human being? And of course, it's the same question with researchers about if you let the computer do everything, then the researchers do what? So because we call it machine learning or deep learning, we train the neural network, but in fact the researcher have to develop the neural network, because currently the AI cannot learn, cannot evolve by make the evolution by itself. So the AI, now we can see, for example, the AI is thinking or learning or something, but it's just following the rule the researcher just given. So you have to define the rule, or you have to build the network first, and then the machine will follow the rule to learn. So the rule is very important for the researcher to build the rule. I'm not sure in the future the machine can really think by itself. But currently, I think it's still a long way to go. Currently, the computers or the machines just can only beat human by calculation, because efficiency of the calculation of the computer are much more faster than human. But for a creative or some real creative work, currently the AI is far from human, cannot reach the level of humans. So somebody is just predicting, for example, within this century, the AI will beat human, or the AI can produce can make a evolution by itself. I'm not sure it will come in this century or not. It's very difficult to predict. Some different researchers just predict this thing from different perspectives. Some people say maybe it's possible, and also a lot of researchers think it's not possible. But let's wait and see. But currently, I can say is for an AI or for a machine can make real thinking work, is still a long way to go.
Yeah, my next question is that if the human is not so good in doing the making the rule, like you said,
Yes.
what happened? Because as you know, as a soil researcher, if we
Yeah.
are not good, our analyze is very simple. Our conclusion also very simple. So in this relationship, the researcher is not good in making the rule. What will happen?
Then the AI or the machine will give a bad result.
Okay.
Yes.
Mm,
Usually,
so
in fact,
they cannot correct you, right?
sorry?
The machine cannot correct you, right?
Yes, usually for a traditional machine learning algorithm, you have to give a how say, a good rule to make it follow. But in deep learning, you just if you just use already trained neural network, you just only have to put more data inside. But you have to make some adjustment to fit your purpose. Yes. But for
Okay.
researcher, have to control the whole network or control the whole algorithm.
Okay. Thank you.
Thank you very much.
I think this is a good point that you raise, Mbak Tung, because this is reflect the importance of interdisciplinary or multidisciplinary collaborations, interdisciplinary collaboration, like in our project, that the computer science, they don't know whether this rendering or this creation or model is really is true or not. I mean, this is, you need some other people to correct you. I mean, to tell you that, okay, this is a model, it's a good model, meaning that the whole process is good. But when you have something that is different, then you can tell the our colleague in computer science, well, maybe you have to change the algorithm, because the model is not, it's not like this. Like, for example, the pictures of the 9th century garment or maybe weapon is not like this one. But so it means then there is something wrong with this process in this algorithm or anything. So that's why the collaboration is very important to have the best result.
Yes.
So you cannot just simply rely on the models, on the process, the computer or the machine process. So this is something that we still have to do to carry out in Indonesia, the collaboration. And I think this is our project. It's an example in how to do this kind of a collaboration between archaeologists, computer scientists, anthropologists, and cultural resource managers. So you cannot just rely on one particular things. Yeah.
Yes, I agree
Okay.
very much. And sometimes for the algorithm, you have to see the result or the purpose of the project to adjust the algorithm. Yes, that's very important.
Yeah.
So you mean that in the process, it should be many times modified, right? You cannot rely only one times process.
Yes, sometimes it's like, for example, we took a photo with our smartphone, for example, the beauty face camera or something. So for some very simple situation, you just press a button to take a photo. Then the result is satisfying. Then it's okay. But for some more difficult situation or some more or some different application. Sometimes smartphone is not enough. You have to use a real camera and then use Photoshop to process maybe. So that's a difference. For some very simple purpose, maybe it's okay, but for some in some other situation, maybe it's not works. You need some other algorithm or some other method.
Yeah, I think did we answer your question, Matung? I think we did. Okay, thank you, Matung. All right, so I see another question in the chat room.
Thank you.
Thank you.
From
Yes,
Harry
thank you very
Purnama.
much.
Okay, thank you, Matung. From Harry Purnama, and he is asking what is the effective method to input things to neural network. So I think you can answer that.
Yes.
Disante?
Yes, it's depending on the target. It's depending on our target. For example, if the target is an image, like in our case, an image, so the input will be a matrix. So that means if you see an image, if you just break down an image, you can see the image was composed by a lot of pixels, right? Each pixel has a value or 3 values if it's a RGB image, RGB channels. So in this neural network, the data was matrix, and the input information was matrix, and the output should be an answer, or also images. It's depending on the different network and your purpose. So I'm not so sure about exactly what do you mean the effective method to input things, but it's really depending on the your purpose, and second, the type of your data. But if you mean how to collect the training data, it should to collect the data either from some public database, or you have to collect the data by yourself. Because in deep learning, to collect the data is really difficult work, because you have to make the correct answer. It's called labeling or annotation. That means you have to tell the machine the correct answer. So if, for example, you get a photo and you want the network to classify the human from the photo. For example, this part is human and other parts are background. It's called semantic segmentation. So you have to make the segmentation first by yourself to let some specialist to annote to make the correct answer for you for training. So also, this is a very important problem in deep learning, that to prepare the data. So very time consuming and consumed some labor work. Yes, I see. I'm not sure is the answer is okay, or because I'm not so sure about the effective method. What does effective method mean? It means how to collect the data or some other things.
Yeah, I think Mas Heru, kalau ada pertanyaan lebih lanjut bisa dimasukkan ke chat lagi, atau kalau misalnya ingin tanya langsung kepada beliau. Oke, sudah. Oh, oke. So it seems he got the point. So
thank you,
Pak Heru. So yeah, there is another point that Dr. Yulan raised in the chat room. So the problem is, if the IT specialist believes that he knows best. I think this is the good point of our collaboration between Tritsumeka, that we are learning it learning from each other. I think this is something that also applies to social scientists and also archaeologists or anthropologists. They think that they know the best. So if everybody thinks that they know the best, then there will be no collaboration, right? So everybody thinks that our method and our technique is the best, and I think we have to work against that kind of thing. This is one thing that I really appreciate from our colleague at Risumekan, Tanaka Sensei, Lee Sensei, Yamaguchi Sensei, Asagawa Sensei, Maeda Sensei, and others, that they don't think as they don't think as a computer scientist. They are thinking as a someone who is engaging in the collaboration project, which means that they know their limits, they know their expertise, and on the other hand, our LIPI and also Balai Konservasi Borobudur also knows our limits, our expertise. So in that sense, that collaboration can work very well. And I think we have to. Well, I'm not saying that I'm not kind of bragging of the project, but I think it's a very ideal process. Yeah, of course there are some confusions that mostly is about administrative things and anything. But in terms of the substance, in terms of the process, I think we work very our collaboration works very well. So I think this is a kind of a model that we can sort of applies to another types of collaborating between different disciplines, especially from the science and technology, and also and with the social scientists. So that's thank you for your raising the point.
Yes.
Okay. Any other questions from the audience, or maybe Bukapus has questions? And do you think that the collaboration worked well, or do you have any things? Okay, silakan, Bukapus.
Okay. Yeah. Thank you, Dr. It's very interesting, your topic, even though I have to admit that I'm not the expert, but I'm very curious, and maybe my question are very simple for you, but since that this event is sharing knowledge, so I would like to use this time to extract from you about cultural heritage, especially with your research. You have already explained that that there are different methods in visualization in Borobudur, yeah, in the surface and the hidden relief and the underground. There are so many different methods. I'm wondering, because you explained, it seems for me is very advanced technology that you have already explained. As far as your knowledge, do that Indonesia already have all that kind of the technology that you have already explained? And the second question is, how many hours that do you spend your time to change from the mono picture to 3D dimension? And the third question, you have already also explained to us about the technology used to look at the underground structures in the Karmawibhangga, yeah, Karmawibhangga. What's the significant finding, or the most interesting finding that you have it from your research? And then from this research, because we look at the Borobudur temple, how many panels that you have already collected from this research? Okay, that's all. I think it's very simple for you. This all simple question.
Thank you. It's a very good question. First, how long we took to get the 3D reconstruction result? In fact, for the process itself is quite fast, because if you already train the neural network, then you input a new photo, maybe only take seconds or only take minutes to get the result. But most time-consuming work was to collect the data and to build the network. So after the network is trained, is built, then when you have a new photo, just input, then you can get the result very quick. And the second question was how many panels? Because currently we only photo scanned how many? It's around 10 or 20 panels of the first level and the 4 Karmawibhangga reliefs for the photo scanning. And from now on, we also collaborating with Mr. Bram, and we can get hopefully we can get more data year by year for the training data. And for the reconstruction of the hidden reliefs, because it's over 100 hidden reliefs, currently we can just input the data and then we get the result. We only can we can show you the result using current algorithm. But I think the most important thing is to collect training data as much as possible. It's not only for training, but also for the very detailed reconstruction for the whole part. And another question, can you pardon me the second question? I thought it was about the collaboration.
The most interesting.
It's interesting finding.
Oh, interesting finding. Sorry.
From your Karmawibhangga.
Yes. That's also the thing I want to mention. That's very important. In fact, the most interesting finding should be it should be a collaborative research that we have to ask our colleagues, that archaeologists, Dr. Fajiao and Mr. Bram, and our friends in LIPI and in Borobudur Conservation Office, because usually the funding should be archaeologist way, and also it should be cultural funding. So we are doing our best to provide the technology to visualize the heritage as good as possible according to our best knowledge. But as also the previous audience just mentioned that it's not we believe the result is the best, but we try our best to provide a better result that we believe using this algorithm to get the result better. And also we provide the result to our colleagues and let them to decide whether this result just fit their needs. So let them to give some feedbacks, and we can improve our research and improve our algorithm to get a better result to fit their needs. So that's the meaning of a collaboration. That's the real it's a very appreciative result of collaboration. So that's a very important thing, and thank you very much. I hope that it's answered your question.
And
yes, Bukadewati?
The first question about the technology.
Oh yeah. Yeah, so she was asking about this technology, and
yes.
it seems that this is well, put it high technology, high tech. And do you think that this is what do you think in Indonesia? Is there any what is the state of the art of this technology that can be used by the Indonesian themselves? Do we have a capability to handle this kind of high-tech technology? If we do, what is the potential and what is the limitation for our cultural heritage management practices or policies?
Yes, I think it's a very good question. And in fact, currently there's a lot of researchers working on machine learning or deep learning. And the algorithm itself is very competitive, and a lot of researchers trying to just propose different networks. But in my opinion, currently for deep learning or the age of big data, the data is very important. So if you have data, then you have the resources to analyze, and you have the resources to make the training data, and you have the data to build your algorithm based on your data. So I think Indonesia have this potential because Indonesia has a lot of very interesting cultural heritages. For example, the Borobudur, of course, and other very interesting cultural heritages. So if you have this kind of data, I think you can make a very good use of it.
Yeah, I think I'll try to answer your question, Gundari. And in terms of the technical knowledge, Indonesia, I think there's no problem with the situation in Indonesia. And there are some people who already knows about this kind of things. And then there are some people, like, for example, like the ITB or any university, and even at LIPI. I'm also I am also inviting some colleague from the Center for Informatic Techniques or something at LIPI, and to join these discussions. And then in terms of that kind of technical capability knowledge, I think there's no problem. But the problem is there are two things actually in Indonesia. One is the resources, because this requires a very high-end capacity, high-end computer facility, which I think in Indonesia already has some. I don't know what's capacity that LIPI has, and in our laboratory in Cibinong. But this is one thing that really becoming a problem for people at the Ministry of Culture and Education, because they don't have that kind of high-end capacity computer. So this is one of the limitations. The second one is again collaboration, because it seems that some computer scientists are not really interested in the issue of cultural heritage, are not really interested in the issue of even a culture recording of cultural materials. And it's very important to get involved to this kind of project, because I think this is one thing that I will say the majority of computer scientists in Indonesia are not really interested in working on this in a cultural heritage issues. It's kind of a bit different from other disciplines like geology or biology, who are already got involved in a project, cultural heritage project, for quite some time. But computer scientists, I think not that many, and maybe only one or two who are interested in in working with cultural heritage material. So this is another problem in Indonesia. So I think did we answer your question?
Yes, thank you.
Okay, thank you, Bundari. Okay, so I have another follow up, another question from Mr. Zulfan Tarik. Oh, this is okay. Can I make this kind of technology by ourselves, and how much cost that I need?
Okay, so if you want to try deep learning, for example, in fact, for the very simple task, you can even use your laptop. Is if you use an already trained network. But if you want to train a network by yourself, and if you want to deal with big data, then maybe a better workstation should be better. Maybe around $10,000 or something, the workstation with a good GPU. Because, for example, in deep learning, the input images were due with as a matrix, right? So a GPU is very good at processing the matrix. So you need a good GPU to build your environment. But if you only want to try some deep learning method, the laptop should be enough. But if you want to make it to a specific application and collect the data by yourself, build the build a network and train a network by yourself, maybe you need a better computer or workstation.
Yeah, thank you, Professor Lee. I think it's a depends. Yeah, depends
Yes,
on what
on
are you
application,
trying
yes.
to achieve.
Yes, the purpose.
Yeah, like the example that I have, that I've been trying to reconstruct the 3D models of the only one panel of reliefs, and I'm using my computer in the office, and then the computer is already almost
yes, because
died.
perspective point clouds, because it's millions of points, and so different points have a different information and millions of them. So there's especially three-dimensional data is require a lot of for example, memories and the computational cost.
Right. Yeah, again, the key word is collaboration.
Sure.
Okay. All right. So do we have any other questions from the audience? Let's see. You can ask the question in bahasa Indonesia. Bisa tanya dalam bahasa Indonesia kalau mau ada yang ingin ditanyakan, nanti akan saya terjemahkan ke bahasa Inggris. But while waiting, if there is another question, I have a very general question to the sensei. And
yes,
you are saying earlier that this deep learning is very useful tools or method in our project, especially because we have the situation where the some of part of the reliefs, the Karmawibhangga relief, or still already buried,
yes,
and there is no ways to get a direct access to the relief, to do photogrammetry, direct photogrammetry.
yes.
But can you tell us another example of the use of this kind of method, the deep learning and machine learning,
Yes.
that might be useful for our colleagues in Indonesia? What kind of a situation that deep learning and machine learning method will be very much useful?
Yes, just let me to give a very simple example. For example, you can use machine learning or deep learning to classify a human or some object from a photo. So for example, you have an ancient photo, you want to analyze the content of the photo. So you can use deep learning to just extract the human. And even you can recognize what his emotion and what his posing or something. So you can use deep learning to extract information from a photo and to help your analysis. And in fact, currently deep learning are quite commonly used on self-driving vehicles, right? So you use some 3D information and use deep learning to let the vehicle or car to make a decision by itself to self-driving. So it's now self-driving vehicles are quite a hot topic, which I think most of the algorithm somehow connected with deep learning or machine learning.
Can we use the deep learning method to reconstruct something that, for example, a part of the building that has been missing? Because this is very important in Indonesia, because we have many parts of the building are already missing, but now we also do not have the pictures of the building. But
Yeah.
can we use this kind of comparison with other building, at the temple, for example, in
Yes.
order to reconstruct the how this particular building look like?
Yes, I think it's possible. First, if you have a lot of buildings like with the same style, then you can use those buildings as references to use a machine learning or big learning to deep learning to reconstruct the missing parts. The other thing is if unfortunately you don't have similar buildings, you can even just, for example, to mark some points, key points manually, and then use upsampling or something based on deep learning to just to upsample, or we can say it's just to make the whole a flat part. So it's also another thinking. It's really depending on the situation and depending on the purpose and depending on what kind of data you have.
Yeah, I think it's the availability of data is very important in this.
Yes, so we have to adjust our algorithm according to the data and our purpose. So that's why collaboration is very important.
Yeah. All right, thank you. And I have another question. This is from Yusril. Whether this technology can be applied to buildings or objects that have non-fixed positions, like a floating building or a boat, for example.
Yes, it's possible, but if you want to reconstruct the exact position, then you have to use some post-processing. For example, you have to make a registration or something to put you can just reconstruct the different parts separately, and then use some post-processing to put it at the correct position called registration or some other post-processing. But the target itself is you can do it separately. It's no problem.
Okay. Yeah, thank you. Yeah, Pak Mas Yusril. If you don't have any follow-up questions, I think if you have any follow-up question on that question, and I'm not sure about floating building and building that floats, something that I think it's any kind of a moving object can be recorded in a static positions. I mean, a boat, you can just ask the boat to stop and then record the data. But I'm not sure about this moving boat. Do you think that the boat is always moving and things like that? Yeah.
Yes.
If you have any, yeah.
Yes, in fact, this, for example, the photo scanning. If you have a lot of photos, you have a lot of cameras, you can take a photo at the same time. So then you can capture the scene within seconds. So the movement is not important if you have a lot of cameras. But if you only have one camera, for example, you have a drone or something, maybe when you make the measurement, it's better to make the object stay.
Yeah, and I think Tsumekan have already done that kind of thing with the digitizing the Gion Matsuri floats, and the floats is actually a moving object, but you have it recorded in a static positions, right?
Yes,
and
yes.
then use that as a kind of a model to create the processions.
Yes.
Simulation of processions.
Yes. After we got the data, and then you can put it and fuse it with backgrounds.
Yeah. Yes, thank you. Okay, so any other questions from the audience? Let's see. I think we don't have any other question, or maybe we can. Maybe Professor Tanaka has some point to add.
Oh well, yes. Well, I have nothing to add to the Professor Lee, but I just want to say thank you very much, and to all our international collaborator. It's our great honor and the happiness to have the collaboration with you. Thank you very much. About the professor, about the Dr. Ganebate's question, how many panels and blah blah. Well, yes. The situation is this. Well, after a few year long preparation, in the last year, November, real scanning just started. And just after that, COVID incident comes. That's the reason. So we are very unhappy with that. But anyway, after the COVID, we begin our real scanning. But anyway, because of our collaboration, we have enough time to make the deepen the collaboration about social scientific field and the computer science field, the deep learning, visualization, and archaeology, and we are very well ready. And we need some time to set up such a collaboration. That now we have I believe now we have very good situation and mutual understanding. So we want to work together from now on too. Thank you very much. And thank you very much for giving us the chance to give the lecture. Thank you.
Thank you, Tanaka Sensei. And I think this our collaboration will not only limited to Borobudur. And as you know, as Bu Dari mentioned, and I mentioned earlier that this kind of method or techniques can be used in other contexts. And I think it's your transparent visualization method and also photogrammetry. And now it's becoming more popular in Indonesia, and then people are trying to use this laser scanning. They already did some things, and some people already using LiDAR. But I think the most important part of this project, your expertise in working on the algorithm to create the transparent visualization, and also in terms of the deep learning and machine learning, and that things has not yet been developed in Indonesia because of the limitation of this equipment and other things like collaboration and others. So yeah, we are looking forward to continue in our collaboration and project. And okay, so is there any other things, question from the audience? So let's see. Yeah, I don't see anyone from the Borobudur office. Is there anyone from Borobudur Conservation Office would like to add something? From the archaeology department? No? Okay. Okay, so I think because there's no more questions, and I think we have to conclude our presentation. And thank you so much, Professor Lee, for giving us the presentation and kind of give some kind of introduction of how we can use the machine learning techniques for heritage visualizations. And I think this is a very important tools and method that we can develop furthermore. And thank you also, Professor Tanaka, for joining the webinar. And I hope that we will be, having another time to talk and then discuss this topic in our work. And thank you, Professor Lee, for giving an update on the result, the interim result of our project. And we will talk more in the near future about that. And terima kasih Bapak-Bapak, Ibu-Ibu, teman-teman semua. Mudah-mudahan webinar kali ini bermanfaat sebagai salah satu informasi singkat tentang pemanfaatan teknologi dalam manajemen warisan budaya di Indonesia. Dan mudah-mudahan ini informasi singkat ini bisa bermanfaat bagi teman-teman, sehingga nanti bisa dikembangkan lebih lanjut untuk melakukan kegiatan baik itu penelitian di cagar budaya maupun perekaman dan pengelolaan database tentang cagar budaya di Indonesia pada khususnya. Nah, untuk selanjutnya silakan diikuti dari Facebook dari Pusat Penelitian Kewilayahan P2 Kewilayahan LIPI dan Instagram P2 Kewilayahan LIPI untuk informasi-informasi selanjutnya tentang acara-acara webinar dan diskusi yang ada di Pusat Penelitian Kewilayahan LIPI. Jadi kita punya beberapa seri di sana, ada yang seri tentang Areascape, tentang studi kewilayahan. Kemudian seri yang ini, seri tentang Science, Technology, and Society. Dan juga kita punya seri tentang studi-studi tentang kewilayahan yang terkait dengan daerah-daerah wilayah tertentu seperti Cina, Eropa, dan Afrika. Dan kita punya juga seri yang namanya Roots to Africa untuk membicarakan atau berdiskusi tentang tema-tema yang terkait dengan Afrika dan juga seri yang terkait dengan penelitian tentang Jepang. Jadi silahkan diikuti website kami psdr.go.id dan Instagram kami Kewilayahan LIPI dan juga YouTube kami dan Facebook kami Kewilayahan LIPI. Saya rasa itu saja, and terima kasih Bapak-bapak, Ibu-ibu semua atas waktunya. Thank you so much, Lee Sensei, Tanaka Sensei, for your participation and for your presentation, Lee Sensei, and for your participation, Tanaka Sensei, in our webinar. And hopefully we will be keep in touch. And thank you also, Bu Ganewati Wuryandari, for your time and for joining our webinar. Again, stay safe, stay healthy, and we'll keep in touch soon. Terima kasih Bapak Ibu, kawan-kawan, kolega semua, sehat selalu dan sampai ketemu lagi di acara webinar P2 Kewilayahan LIPI yang lain. Baik, thank you.
Thank you very much. Thank you very much for having me here, and thank you very much for the questions. And looking forward to seeing all my Indonesian friends soon.
Hopefully, yes, hopefully. Oke, terima kasih, izin untuk ditutup. Silakan Mbak Fatma ditutup. Terima kasih.